Simultaneous equations, let's have a look at them. I guess the most common way of solving simultaneous equations is what's called the elimination method. So we want to eliminate a variable. Then we go and solve it for the other variable. And once we've got that, we substitute back in and we can get both of them. So here's a fairly typical sort of one. The idea, well, we want to make the coefficient of x or the coefficient of y the same. Well, when I say the same, it's really the magnitude. We don't care about plus or minus. So I wonder which one I eliminated, the x's or the y's. I reckon I would have eliminated the y's. Let's see. So I'm going to multiply the first one by 2 and the second one by 3. Sure enough, I've made the y's the same. So in this case, we subtract, giving me 11x is negative 33. X is negative 3, found my variable. Now I can substitute it back into, well, I've got 4 equations I can choose from. It really doesn't matter which one I substitute into. And we end up with y equals 9. Now remember, the answer to this question is x equals negative 3, y equals 9. It is not the coordinate minus 3, 9. Just because I've used the pronumerals x and y doesn't automatically mean it's a coordinate we wrote there. No, we answer it. If it happened to be a coordinate geometry problem and we were using this idea to solve a problem, then okay, we'll write it as a coordinate. But that's not what we're doing here. There's another way of solving simultaneous equations. Here, I can't really eliminate because I've kind of got 4 pronumerals there. Because x squared is of course different to x and y squared is different to y. So this one is, well, the substitution method we call it. So we make either x or y the subject. I suppose for this one it doesn't really matter. Y is probably the smarter one because it's already 1y, makes life a bit easier. We have 14 minus 2x. Substitute it into the other one, and if I expand it out, there we go, we end up with a quadratic. Does 3 go into everything there? It does not. 3x minus 41, x minus 5 is how that factorizes. We get 2 possibilities for x. Substituting back in, we get 2 possibilities for y. It's important we match the x with the y when we write the answer. It's not good enough just to say, well, x is this or this, and y is this or this. We need to match them up. So my final answer then is, well, x is 5, y is 4, or the other possibility, x is 41 on 3, y is negative 40 on 3. Well, there's no reason why we should have to be stuck with 2. Anytime you've got the same number of pronumerals as you do equations, assuming one of the equations is not just a multiple of another, theoretically you should be able to find all the pronumerals. So I've got 3 equations, 3 pronumerals. Which one did I delete? Well, I'm going to create 2 new equations. I'm going to eliminate the same pronumeral from both equations. So the first one I'm going to multiply by 2. So there it is, 2x plus 4y minus 2z, and the other one I've got there is 2x minus 3y plus 4z. So I can eliminate the x's from these two. And that gives me 7y minus 6z is 38. Now I pick another pair and also eliminate the x's. So now I'm going to multiply the first one by 4 and match it up with the third equation. And now we can eliminate the x's. It's now become what we're used to seeing. 2 equations, 2 pronumerals, and I'll eliminate the z's out of this one, so I'll now multiply that 3y minus z by 6. I now know y is negative 2. I should now be able to work my way backwards and work out all the other pronumerals. So to work out to work out z, we just found y, we get z equals 4. Substituting that back in, I get x is 3. I have my final answer. Interestingly, if I was to turn this into a coordinate geometry problem, what have I just done? Sorry, so what am I talking about then if I've added a z-axis? Right. It's now a 3-dimensional space instead of a 2-dimensional space. So we've found the point of intersection for 3 lines in a 3-dimensional space. That's basically what that would be. All right. So 1G, handful of questions there on simultaneous equations.